Hello and welcome to Computer Science 40S. This is Greenfoot Chapter 3. And at this point here, I've decided to start breaking the videos down into smaller chunks. So if you need to go back and watch a smaller section, you can do that easily. So this video will just discuss 3.1, which is on page 31 in your book. So it says, in the previous chapter, we looked at the basics of starting to program our first game. There were many new things we had to look at. Now we'll add more interesting behavior. Adding code will get a little easier from now on since we have many of the fundamental concepts. First thing we're going to do is add some random behavior. Now, before I uh, go on here, I taught many people this in earlier grades. Um, Greenfoot does something really interesting. It actually automatically saves for you. Um, there's a problem with that. It's great to have an automatic save, but the problem with that is that you don't get to keep old versions. So what I'm going to recommend that you do from here on in is as soon as you start something new, save it as a working copy. So here I have my little crab. I've been away from making videos for a while, so I'm hoping that I'm okay doing this here. But you should have void act if it's at the edge, turn 17, otherwise move 5. So this is where you're at. You have this working. Let's not mess this up. So what I'm going to recommend that you do is, I'm going to just close that. And I would recommend that you go save as. And I've got one called Little Crab Worked that I was just testing out here. So I'm going to call it Little Crab Worked or working copy, something that tells you that this is the one that you're now working on. It's not complete. It may have errors in it. If you've got the previous chapter's working one, then you can always go back to that. That's the one major problem with these automatic saving. So go ahead and save it as a working file. Oh, I had a little problem there. And I got a problem because I've already done it, but that's how you would do that. So you should be fine with that. And I'm going to open up the source code here as well. Okay, so let's get started here on 3.1, adding random behavior. In our current implementation, the crab can walk across the screen and it can turn at the edge of the world, but when it walks, it always walks exactly straight. That is what we want to change now. Crabs don't always go in an exact straight line, so let us add a little random behavior. The crab should go roughly straight, but every now and then it should turn a little bit off course. We can achieve this in Greenfoot by using the random numbers. The Greenfoot environment itself has a method to give us a random number. This method is called getRandomNumber, and it expects a parameter that specifies the limit of the number. It will then return a random number between 0 and the limit. For example, Greenfoot.getRandomNumber20 will give us a random number between 0 and 20. The limit 20 is excluded, so the number is actually in the range of 0 to 19, but you'll notice that that's actually 20 numbers. The notation here is called dot notation. That's an important thing that you should know. When we call methods that were defined in our own class or inherited, it was enough to write the method name and parameter list. When the method is defined in another class, we need to specify the class or object that has the method, followed by a period, dot, followed by the method name and the parameters. Since the getRandomNumber method is not in the crab or actor class, but in a class called Greenfoot, we have to write Greenfoot dot in front of the method call. Now a note here about static methods. Concept over on the left-hand side in green. Methods that belong to classes as opposed to objects are marked with the keyword static in their signature. They are also called class methods. And the note is methods may belong to objects or classes. When methods belong to classes, we write class name dot method name parameter to call the method. When a method belongs to an object, we write object name dot method name to call it. Both kinds of methods are defined in the class. The method's signature tells us whether the given method belongs to objects of that class or to the class itself. Methods that belong to the class itself are marked with the keyword static at the beginning of the method signature. For example, the signature of Greenfoot's getRandomNumber method is static int getRandomNumber int limit. This tells us that we must write the name of the class itself, Greenfoot, before the dot in the method call. We will encounter calls to methods that belong to other objects in later chapters. Now, to be perfectly honest, I don't really have a good handle on the difference between these different methods, but hopefully in a later chapter that will become clear to all of us. Okay, so back to the actual work here. Let's say that we want to program our crabs where there's a 10% chance at every step that the crab turns a little bit off course. We can do the main part of this with an if statement. So if something is true, turn 5 degrees, I guess. Now we have to find an expression to put in place of if something is true that returns true in exactly 10% of the cases. We can do this using a random number using the Greenfoot.getRandomNumber method and a less than operator. The less than operator compares two numbers and returns true if the first is less than the second. Less than is written using the symbol less than. For example, 2 is less than 33, and so on. You guys know this. Okay, so exercise 3.1. And let's just see here. I don't recall if that is in the worksheet or not? Yes, it is. Well, here you've got to do some, write the method call that will produce a random number in this range 0, 1, 2, 3. So you should go ahead and do that. You've got some stuff to fill in there. Then you can fill this in right here. This is exercise 3.1. And 3.2 is write down another expression that is true 7% of the time. So that's right here. I suggest you pause the video for a moment. Okay, so if we want to express the chance in percent, it's easier to deal with random numbers out of 100. An expression that is true 10% of the time, for example, could be Greenfoot.get random number 100 less than 10. Since the call to Greenfoot.get random number 100 gives us a new random number between 0 and 99 every time we call it, and since these numbers are evenly distributed, they will be below 10 in 10% of all cases. We can now use this to make our crab turn a little in 10% of its steps. So here's the actual code. Let's go back to Greenfoot. I've discovered that this works quite well. You get one window on the side and the code on the right-hand side or left, whichever you prefer. Okay, so we've got if at edge, we're going to turn 17. Instead of we're going to add in here. So after this little statement here, the if, we're going to go if Greenfoot dot get random number of 100 that's less than 10. Brace. We're going to turn 4 degrees. And there's the end brace, which lines that up. And that should work. Notice that down here it says no syntax errors. When I go over here, you'll see it's still like this. That means it's got to compile, but when I click there, it's going to recompile. And let's just make a new crab in there and see what happens. And because my window's a little bit smaller, he disappears a little bit. But every once in a while, the crab turns a little bit to the right, 4 degrees. Okay, flip the page, page 34. Exercise 3.3. Try out the random course change shown above in your version. Experiment with different probabilities for turning. So you can play around with that if you want. This is a pretty good start, but it's not quite perfect yet. First of all, if the crab turns, it always turns the same amount, 4 degrees. Secondly, it always turns right, never left. What we would really like to see is that the crab turns a small but random amount to either its left or right. We're going to discuss this now. If you want to try this on your own, go ahead, pause the video, try it out on your own, and then I'll show you how to do it. If not, here we go. The simple trick to the first problem, always turning the same amount, is to replace the fixed number 4 with a rather random number. So in other words, instead of this turning 4, we're going to replace that with, let me just copy and paste here. Copy, Control C, Control V, and we're going to turn it a random number between 0 and 45 degrees. Okay, let's just see if that works. No syntax errors. There, now he turns different amounts every time, but still always to the right. Okay, so exercise 3.4, try out the code, what do you observe, and so on. You can go through exercises 3.4 and 3.5. 3.5 is particularly challenging. I guess you could try it on your own, and if you do want to do that, go ahead and pause the video here. Otherwise, I'm going to show you how to do that right away. Exercise 3.5 is not as easy at first if you've never seen anything like this before and probably deserve a hint. There is temptation at first to perhaps use an if statement to deal with the two directions, and perhaps some of you that did try it on your own maybe tried that. There's a much simpler solution. Think about it this way. Greenfoot.get random number only gives us numbers with a lower bound of 0. We want numbers from minus 45 to 45. That means that we want roughly 90 different numbers. So we can get a range of 90 numbers using the Greenfoot.get random number 90, but this gives us 0 to 90. How can we go from 0 to 90 to minus 45 to 45? The answer is this. We can get random numbers out of a 90 and then just subtract 45. Figure 3.1 attempts to illustrate this, and you can look at the picture on the top of page 35 and see that. Note that this is actually out of 1. The range of the random number is actually 0 to 89. So after subtracting 45, we end up with minus 45 to 44. But since we don't really care about accuracy with our random turns, it's okay. So to actually do that, we're going to get a random number between 0 and 90, like so. And then important to put this in the correct spot, minus 45 right there. So in other words, we're going to get a random number between 0 and 90, and then we're going to subtract 45 from it, and then we're going to turn it. And if all my indentation and my brackets are right, we should get this to work. And you can see that sometimes he turns right and sometimes he turns left. Now, what happens if I have multiple crabs in here? I'm just going to make the window bigger so we can see this better. And you will see that they all move independently. And that's because each of these crabs is its own object and it's running its own bit of code. It's getting its own random number. Okay, so that's the end of section 3.1. I'm going to stop this video here and create a new one for 3.2.